Hello, fellow problem solvers. So they're going to be doing a problem that you've been waiting for me to do. You've been waiting for me to do the Pranav Sriram's Olympiad Combinatorics. And we're doing the first problem from the algorithms chapter 1. Namely that in a graph G with n vertices, no vertice has a degree greater than the triangle. So that, or delta. Show that one can color the vertices using at most delta plus 1 colors such that no two neighboring vertices are of the same color. So what does this really mean? It means like this graph has like you have these endpoints, right? And which is a vertex and vertices. And every vertex has the most delta edges from it. Like so, let's say if delta was 2, every vertex could have at most 2 edges from it. So this is like the maximum for like this vertex could have like an extra edge. No, it could not. This would be its maximum. And now we need to show that we could color this in 3 colors such that no two connected ones are of the same color. Now, with this problem, I invite you, if you want to try it for yourself, I invite you to try it out for a minimum of 5 minutes, ideally 15 to half an hour, but not more than an hour and a half. If on the other hand you'd like to go along with us, put your first ideas out on paper for the next 15 minutes. And now without further ado, let's begin. So, how would I go about doing this problem? For me, n vertices, this sort of fixed degree thing, the first thing I see when I see like n vertices, like this, is what happens if I try induction? So, say for some n, I'm done. For n equals 1, I'm obviously done. I just color that vertex and I have no problems. And now what happens when we add a vertex? And when we add the vertex, say the delta is the same. Say we're adding vertices, we're doing induction on n. Now what happens when I connect n to some of these and I'm trying to pick a color for n? Well, n has at most delta neighbors, right? So delta neighbors, delta of these edges. And these neighbors are colored, so it means n, this new vertex, can't be colored in at most delta of the available colors. But given we have delta plus 1 available colors, that means there is going to be at least one color with which we can color this vertex, and so we are done. Now, the book, and this actually solves the problem, this is good enough. Now, the book actually, what it does, it goes in a different direction. It says, let's create an algorithm for how we're going to do this. And it says, start at a random vertex, not a random, like whichever, doesn't matter which one, and always color the vertex, like name the colors 1 through, what's it called? Delta plus 1. And always color the next vertex with the smallest available color, right? With the color that has the smallest available number. And it goes through a similar logic saying you will always be able to color it. Now this solves our first problem from Pranav Sriram's book on Olympiad Combinatorics. Let me know if you have any specific other problems you would like me to tackle. And as always, thanks for problem solving.